Welcome to another video from explainingthefuture.com. This time I'm going to explore the future of nanotechnology. In particular, I'm going to talk about molecular self-assembly, what we could call nanotechnology 2.0, which in the future may allow the local manufacture of almost anything we can imagine. Nanotechnology is the engineering of matter on a molecular or even atomic scale, with 1 nanometer being just 1/1000th of a meter in size. Since early humans first made primitive tools, we've been using technology to manipulate clumps of atoms. Even so, almost all manufacturing processes still move atoms around in a fairly imprecise manner. Indeed, if we imagine these plastic bricks to be atoms, or even molecules comprised of many atoms bonded together, then most current manufacturing methods are akin to making things out of Lego while wearing boxing gloves. Certainly, we can move the atoms and molecules around. But we cannot precisely control where each individual one of them ends up. It's often said that nanotechnology allows us to take our metaphorical boxing gloves off in order to manipulate individual molecules and even individual atoms. For example, microchip manufacturers like Intel use a photographic process called nanolithography to make microprocessors. This projects images of circuit layers that are chemically developed into nanoscale components that can be as small as a few hundred atoms across. Nanotechnology is also already being used to create nanocomposites and nanocoatings. These mix nanoscale additives with conventional materials in order to improve their internal properties or surface qualities. For example, nanoscale particles of silver are now added to some plastics to make them antibacterial, while nanoparticles of titanium dioxide are routinely applied to glass so that its surface rejects dirt and in effect becomes self-cleaning. Tiny lattices of carbon atoms, known as carbon nanotubes and graphene, are also starting to be added to some paints and plastics in order to make them stronger or electrically conductive. In the next decade, the market for nanocomposites and nanocoatings will be worth tens of billions of dollars. But, returning to our previous analogy, it's worth noting that the technology basically involves mixing nanoscale Lego blocks into another material, or chucking them onto a surface, with no control existing over the precise placement of each individual nanoparticle. The nanotechnologies used to make microprocessors and nanocomposites and nanocoatings are based on so-termed top-down processes. In other words, they use traditional scale technology to build nanostructures. However, the future of nanotechnology as a manufacturing process is more likely to involve development of so-termed bottom-up methods. In other words, methods of actually building things at the nanoscale. Now, in theory, we could do this by using a technique called positional assembly, which is where you take individual atoms, individual molecules, you pick them up, move them around and stick them together like a couple of Lego bricks. Now, we know that can work because we've already found out how to use what's called a scanning tunneling microscope, an STM, to actually move around individual atoms. But the problem with positional assembly is that most products contain quintillions of atoms. So the idea of picking them up, moving them around, sticking them together individually, taking them apart, simply isn't going to work. And for that reason, future bottom-up methods of nanotechnology, of nanoscale manufacturing, will be based on a process called molecular self-assembly. To understand molecular self-assembly, imagine how a pile of Lego bricks, again representing a pile of molecular components, may be turned into a final object. Our current manufacturing approach is to pick up the individual bricks and to piece them together via a process that will be akin to positional assembly. However, an alternative approach would be to take all the bricks, here they are, look, put them in a container, take all those bricks and to put them into a second container. There they are, all in there, and then we'll put on the lid of this container, give it a really good shake, and we can now take off the top, and of course inside we find a completed object. All of our Lego bricks in this case have put themselves together. Now that might sound absolutely ridiculous, the idea of taking lots of components for something at molecular scale, putting them in a container, giving it a shake, taking out a complete object. It sounds almost like magic. But it really is what the idea of a notion of molecular self-assembly is all about. Molecular self-assembly is a practical possibility for products made from complex molecules that only fit together in one orientation and which will lock into place on contact. When such components are mixed, they will bump up against each other, and when the collision is at just the right angle, they will join together. The idea may sound absolutely ridiculous, but we need to remember that all living things, ourselves included, are manufactured from individual molecules that self-assemble without the intervention of production tools. The idea of developing nanotechnologies capable of self-assembly was first introduced by Eric Drexler in his 1986 book Engines of Creation. This imagined a future in which we would learn to manipulate individual molecules and even individual atoms in order to fabricate any product we desire out of very basic raw materials. By 2001, Drexler's work had resulted in the establishment of a National Nanotechnology Initiative in the United States, followed by the National Center for Nanoscience and Technology in China in 2003. To date, tens of billions of government dollars right around the world have been invested in nanotechnology. This said, the focus has been almost entirely on short-term developments in areas such as nanocomposites and nanocoatings. Even so, advancements in genetic modification, synthetic biology and protein engineering are now starting to be used to self-assemble custom DNA. Complex artificial molecules called foldamers have also been created and are very much like molecular Lego pieces with complex bumps and hollows that define precise patterns of interconnection. In March 2014, a team led by Martin D. Burke at the University of Illinois even developed a molecular 3D printer that additively self-assembles small carbon-based molecules. The science may be in its very, very early days, but already artificial molecular self-assembly is beyond science fiction. The idea of nanotechnology 2.0 may be difficult to get your head around. This said, molecular self-assembly is already the technology of life itself and could lead to a far more radical revolution than that of the microprocessor or the internet. To understand more, you can always look in my book, The Next Big Thing, which is all about the future of nanotechnology and other related future developments. But now that's it for another video, and I hope to talk to you again very soon.